Hi, my name is Darasimi. I'm going to teach you how to factor polynomials and division with polynomials. So before I begin, I would just like to tell you guys about ACE Tutors. So ACE Tutors is a nonprofit program that tutors kids for free. All of the classes are taught online, and it has a variety of courses from mathematics to sciences to pre-honors prep. It tutors classes such as pre-algebra, algebra 1, geometry, algebra 2, geology, basic physics and chem, astronomy, pre-honors prep for honors English and honors physics, and it also tutors math for kids in 1st grade through 6th grade. Classes are taught by credible tutors who have all passed their classes with flying colors. Make sure to join our Google Classroom using the code in order to gain access to this slide and more resources that can help you learn this topic. The code is M2MUUF7. Okay, so there are a lot of different ways to factor, such as the GCF method, factor by grouping, summing difference of cubes, difference of two squares, general trinomials, completing the square, and the quadratic formula. The ones that are above it are the methods that I'll be teaching. So, this is just general trinomial. You should know this before heading into the lesson already. So I'm just gonna skip over this. So the GCF method stands for the greatest common factor. This is when we find the greatest common factor in polynomials to fully simplify it. So for example, for 3x squared plus 27, we can factor out a 3 and we're left with x squared plus 9. That's the GCF method. 3 was the greatest common factor that we could take out. For 9x squared plus 8x plus 4, because there is no GCF, then that's as simplified as it gets. We can't really factor it any further. For 2x to the 4th plus 8x plus 16th, we can factor out a 2, and we're left with 2 multiplied by x to the 4th plus 4x plus 8. Okay, the next method is factor by grouping. Normally we use this method when we have a polynomial with 4 terms, but you can also use this method with 3 terms, but it's not as common. So the first step is to split the polynomial into 2 groups, as is already done here. Split the polynomial into 2 groups, as is already done here. This is the first group, and this is the second group. Second, factor out any common factors from each group. So like in this group, we can factor out an x because that's the greatest common factor. In this group, we can factor out a 2 because that's the greatest common factor. And next, you group the factor terms together and multiply it with the remainder terms. So this is the factor term 2x plus 5, and you multiply it with the terms that you factored out from it. So x plus 2, that's your final answer. And an important fact in this is that the terms that you factor out have to be the same. So like for this group, we factored out an x, and for this group, we factored out a 2. The remaining values after we've taken out the GCF have to be the same. If this one said 2x plus 3 and this one said 2x plus 5, we couldn't work with that. They have to be 2x plus 5 here and 2x plus 5 there. Okay, next method is sum and difference of cubes. We only use this method with cube terms, and it is always in the form a to the power of 3 plus b to the power of 3. Basically, we would find the base, and then we would break it down into this. So a would go here, b would go here, and we would multiply by a. We multiply by the square of a minus a multiplied by b plus the square of b. And regarding the whether it's positive or negative, we have to remember SOAP. Whether it's positive or negative depends on its original depends on it whether the original problem is positive or negative. So like for this, because this is positive, SOAP means same, opposite, and always positive. So because this is positive, this would be same. So same as the original value. Because this is opposite, negative is opposite of positive. So that would be a minus over there. And because this always stays positive, it doesn't matter whether this is negative or positive, it always stays positive. Whether the sign is positive or negative depends on the sign of the original equation. This is the original equation, and this is the new factored out equation. Okay, the next method is difference of 2 squares. It's similar to the method sum and difference of cubes, except we only use it if the sign between 2 squares is negative. SOAP is not used here. Examples of situations where we would use it is a squared minus b squared, and examples of situations where we would not use it is a squared plus b squared. How we would factor it. So you always have to find the base, and the base is just like that a, b without the squared section, without the power of 2. We would find the base, and then we would multiply it by the same values, basically the base, the same bases, the same numbers, a blank being a blank b, but the whether it's positive or negative, no, it would be positive or negative. One value will have to be positive and the other value will have to be negative. So it's always has to be negative, and this always has to be negative, and you can always factor it out to have one positive symbol and one negative symbol. The next method is the quadratic formula. Normally, this method of factoring is used if none of the other methods of factoring do not apply to a polynomial, but you can use it whenever you're stuck on a question and you can't seem to find the answer. The quadratic formula gives you the answer in number form of a polynomial. It's not really a simplified version of it. So for this equation, if we were to use the quadratic formula, 3 would be A, 5 would be B, and 2 would be C, and then we would just plug it into this to find the answer to this equation. Okay, now we're on to different ways to divide polynomials. So there are only 2 different ways to divide polynomials without using a without just like plugging it into a calculator, and that is long division and synthetic division. So let's start with long division. Long division with polynomials is the same as long division with numbers. The only difference is the variables and the remainders are put into a different form. So like long division with 2x squared plus 7x plus 6 divided by x plus 2, we would basically multiply x plus 2 as many times as we needed to in order to get like the first 2 terms, in order to get the exact value of or something close to it. But basically, at least in order to get something the exact same value as the first term. And then the second term, we would subtract that, because we're subtracting all the values from each other. We would subtract that, and then we would get that answer, and we would try to see if any of these go into that. If any of these go into this. And because x plus 2 does go into this, if we multiply it by 3, and if we subtract 3x plus 6, we would get 0. If we get 0, that means that there is no remainder. But for this, yeah, same thing. We got 0, that means that there is no remainder. But if we were to get a remainder, basically the way we would write that is we would write, let's say the remainder was 3 for this equation. We would write 3 over x plus 2. Let's say the remainder for this was 8. We would write 8 over 2x plus 6. You would basically put the remainder over the divisor. Okay, next is synthetic division. Synthetic division can only be done if the divisor is a polynomial that has only one variable to the power of 1, such as x plus 1 or x minus 3 or x plus 8 or x minus 4. It cannot be done with polynomials such as x squared minus 2 or x squared minus 3x minus 6 or x to the power 4 plus 8. The exponent, as said earlier in this, the exponent always has to be 1 and the coefficient always has to be 1. Basically, to do synthetic division, we would first find the root, and to find the root of a function, we would just equal it to 0. So x plus 3, 2x to the third minus 5x squared minus x plus 3 divided by x plus 3. First, we have to find the root, and we know the root is negative 3. And so we would make this sort of table. We would put negative 3 to the side here. And then we would put each of these values, 2, 5, 1, negative 1, 2, negative 5, negative 1, and 3, as a list, as these tables go. And the first value that always comes first, we never multiply it by that. We basically just bring it down, and then we multiply that by the negative 3, and then whatever value we get, we put it here, and then that by -3, multiply that by -3, whatever value we get, we put it here, multiply that by -3, whatever value we get, we put it here, and then simplify it. And if you're left with a number, you have a remainder. If you're left with 0, you don't have a remainder. And as I said before, there's a specific way to put things in a remainder form. You would basically put the values that you got. It starts from number, by the way. So this would be the remainder, this would be a number, this would be a value with x, this would be a value with x squared. So like the larger the numbers you have, the more the terms go up, like x to third, x to fourth, x to fifth, and so on. So this would be 2x squared minus 11x plus 32 plus -93 over x plus 3. And yeah, that's it. Thank you for listening, and make sure to join the Google Classroom Code for ACE tutors to get more to get access to this slide, and as well as more practice problems.